Don't just copy your nose. Gotta read them. Gotta read them.
Hell. Oh my god.
Just for laughs. Just for laughs. As you can hear, that person in the background is just for laughs. Just for laughs. This right here, like this is just for laughs. You know, the math is serious. Remember, you got to write everything down unless I tell you not to write it. So everything on the video got to be in your notes. Ladies and gentlemen, once again, this is 5.3. Use angle bisectors of a triangle. This is Fraser Nation. We add it once again. Students will be able to use angle bisectors inside of a triangle. Okay? In geometry, it is always about what's in the name. We're going to take and bisect angles. We're going to take an angle. We're going to take an angle. And we're basically going to divide it by 2. Okay? That's really what we're doing. That is really what we're doing. So remember, an angle bisector means cutting the angle into 2 congruent angles. So if I have an angle, see my angle right there? I'm going to cut that sucker in half. Okay? So we know that these 2 angles are not going to be congruent. So if the whole thing was 20, this would have to be 10, and this would have to be 10. Okay? Every point that is on your perpendicular bisector, and this was in chapter 2, I don't know if you remember that or not, but every point like that right there, it has to be perpendicular, okay? So that's what this point says. It has to be perpendicular. So if you don't see these perpendicular, this is not your bisector. Let's see, we know this already. Array, so remember, array is a line segment with 1 arrow. Upside down T means perpendicular or 90 degrees. You guys know that already. Concurrency means meeting at the same point. So if I had this and I had this meeting here and I had this right here, concurrency means that we're meeting at the same point. And just so you know, interior means inside. Next card. Theorems. So theorem 5.5 says an angle bisector theorem. If a point is on the bisector of an angle, so here we have a bisector right here, and I have point D. Point D is on my bisector. Then it is equidistant from the 2 sides of an angle. So if ray AD, so here's AD, splits or bisects BAC, okay? So this angle and this angle have to be the same degree measure, and it has to be perpendicular. So this says BD is perpendicular to AB, so 2 congruent angles, meets at a right angle, meets at a right angle. If you have these 2 conditions, okay, you have that going on and you have these 2 going on, then you can say BD is congruent to DC, okay? Put a little congruent there. Remember, converse means backwards, so the backwards is also true. If you have right angles, okay, with an angle bisector, and you know that AP and PB are the same, so you know this as well, then you know that PC is your angle bisector. So if bisector and right angles, then you know that these are equal. If these are equal and they're perpendicular, then this is a bisector. Okay? Basically, you kind of have to read it a couple times, make sense of it. We can kind of hop into some examples. So here we go. In the following examples, find the value of x. Well, we know we have an angle bisector because 2 things. Number 1, we have the right angles, okay? And these angles are the same. This angle is 27, this angle is 27. So that means that this is going to be the same. So this means that right here, this is just simple. According to the angle bisector theorem, x has to be equal to 15. Okay, so number 1 is done. Number 2, I'm telling you that we have a point, we have perpendicular, and we know that these sides are congruent. So that means these angles should be congruent. So this has 1 band, and this has 1 band. So that means we have to put our equations together. So I have 3x plus 5 equals 4x minus 6. Combine like terms, so subtract 3x on both sides. That crosses out. This is going to be plus 6 on this side because we want the x's on one side, all the numbers on the other side. Just check me if you think my math is wrong. And 4 minus 3 is going to be 1x, so I have x equals 11. Okay? There it is right there. Number 3, same thing. I have right angles, okay? And so basically, if you know that these are the congruent angles as well, then you know that these sides have to be congruent. So I have 6x minus 5 equals 5x. Basically, we want to get, like, the only thing we can do, we want to get this number by itself. So we have to subtract 6x on both sides. We want to get that negative 5 by itself. So cross that out, and we have negative 5 equals negative x. Divide both sides by negative 1. And so you have x equals 5. Because when you divide two negatives, they become positive. So there you go. And finally, number 4. I cannot do number 4. Why can't I do number 4? Because there is no perpendicular here, okay? Since there is no perpendicular, I don't know that these two angles are congruent. So IDK x equals to 36, because I don't even know if this is the angle bisector. Okay, I don't know that. I don't know if angle bisects or bisected. Okay, so you have to be careful. You need the perpendicular, you need these angles to be congruent, and you need these sides to be congruent. One more example I wanted to show you. Do you have enough information to conclude that QS, okay, so ray QS, so here's QS, start at Q, go through S. Do we have enough information to say that PQR is bisected? Well, let's look. And we have to explain as well. Well, two things. One, if, okay, we have two perpendicular bisectors. So if PS is perpendicular to QP, okay, and that's true because of the right angle, and we know that SR is perpendicular to QR, okay, so we got these two things down, and we know PS is going to be equal to SR. Since we have these two things, then yes, because of converse of not perpendicular, I do apologize. That's angle bisector. That should have said angle. Yes, because of converse of angle bisector theorem. THM. All right, so you guys kind of have a handle. That's basically all your homework's going to be asking you about. So let's get the homework, and we'll talk another time.